All right, on to part two. So, how else can we manipulate a linked list? We can add a node. What if we tried to add a node to the center of the linked list? So, depicted here, we have a linked list with nodes with values 2, 5, and 3. What if we want to add 6 after 5 and before 3? As so. So in this case, we're making a function that adds a linked list node at a specified index. So we can also make a function that searches for a value instead of finding it by index. But in this video, I'm only gonna do the function that adds the node at a specified index. So let's tackle this. So we can make a function insert at. This function is given a value and an index. So in order to implement this function, we need to create helper functions. So let's think about this. In the case of this scenario, it would be helpful to know what node is at that index. What else? It would also be helpful to know the size of the linked list. Since an edge case that we have to account for is like if the index given to the function is greater than the length of the linked list. So let's implement those two helper functions. So we make a function getAt. So getAt should return the node at that index. So what can we do? So we can make a counter variable, and then we can make a node variable that keeps track of the pointer, the head pointer. Remember that a linked list is defined by its head, so we need to iterate through the linked list and find the node at that index. So what we can do is while node, and then we can step through the linked list with this node variable. And then as we're stepping through, then we're incrementing the counter. And then once the counter reaches the index that we're looking for, then we can return the node. Otherwise, we return null when there is no index, when the index doesn't exist in the list. So let's test this out. So for node For this list, we can do get at 0. We should get the first node in the list. And we get the value 4. So yep, that works. Let's try 2. We get the value 5, which works. Okay, so now we have the get at function that gets the node at the index. Let's make a function size. So this function will return the size of the linked list. So similar to get at, we can make a counter. And we can step through the list. We define the variable node to be the head. We update this head variable to step through the list. We update this node variable to step through the list. And then we can increment the counter. And then once the node reaches, once there is no nodes to step through, we return the counter. Well, let's test this out. So, yep, so there's 5 nodes in the linked list, so that works. So how do we implement the insert at function? So we can think of edge cases. So what if index is at 0? Yeah, what if the index is 0? So if the index is 0, then we're inserting at the head. So we're prepending the linked list. So we can do if index is equal to 0. This dot prepend value, and then return the list, which is returning the head node. So let's test this out. So if we do list 1 dot insert at 0, we should get a insert at 0. Let's say 2. Then 2 is appended or prepended to the linked list. So what if the index is greater than the size of the So what if the index is greater than the size of the linked list? So what we're gonna do here is we can do a less than equal to index this dot size minus 1, and then we can do an else. So this is if the index is equal to the size or greater, then we just append the value. and then we return the head. So let's try it, let's test this out. So if we make it like 10, it should just add the value of 2 to the end. Okay, so if the value is inserted to the middle of the linked list, how do we account for this? So we need to update the references. So we can what we can do is we can define a variable previous. And previous will get the node at index -1. So this is the node previous to the spot that you want to insert the index. I mean, you want to insert the node. So we can set the previous pointer. Well, first we want to make a new node. And then we want to set the new node's pointer to previous dot next. So what we're doing is pointing the new node's pointer to the next node that is the previous node's current next node. And then we want to set previous.next to the new node. And then we return the head. So let's test this out. Insert. Previous.next. So let's see, what are we missing here? So it's appending to the end. So we wanted to insert at index 3.